Okay, so what is the question? So first we have this triangle ABC, right? So I think it looks cool. I'm not too sure. So anyways, we need to make the incenter now. So uh,
So this is the problem created by Lucas, yeah? Oh wait, you made it.
yeah, I designed it to be as cringe as possible. So like, no, I messed that up. That's my bad. That's my bad. No, no. Okay, there.
Daisies.
No, we have to make it I because these already apply it. Where's the back button? No, it's John. Oh, it's there. Never mind. That's my bad. D is there. Okay, we have to do that. And then this is actually our I. Right. So I is our insender. What the cringe? So what you call it? This is D. Boom. I will I'll get rid of this perpendicular. Okay, so basically so far in our diagram we have a triangle ABC, we have the incenter I, and then we have our incircle, which is tangent the sides BC, AC, and AB at DEF respectively. So what was the thing? Okay, so we have line EF intersect line BC at this point. So at this point here, which we will call P, right? And we'll okay. So after this point P, we'll what do I call it? We define the midpoint of a AI as K, which so okay, so the midpoint of AI is K, EF intersects BC at P, and of course the circumcircle of triangle ABC will define as O. So we'll put that in real quick. Plonk. And okay, where's the sender button? So and we also want the circumcircle of it was BFP. And we want the circumcenter of BFP triangle BFP. Let's just call it G or whatever, right? And we have the circle that passes through G, G, K, and O. What do I call it? This might be cool, but like what do I call it? So we have the circle through G, O, and K, and intersect the circumcircle of ABC on the what do I call it? On the same side of BC as A. We'll call this point Q.
What was G again?
G is the circumcircle of BFP.
Circumcenter of BFP.
Yeah, circumcenter. So this will be point Q. And then you have to show that the circumcircles, so if you consider the circumcircle of QBD and QCD, and then you consider the, what should I call it? Where is it? What's the tangent? Where's the tangent button? No, where's the tangent button? Here it is, here it is. So if you consider the tangent to QBD at B and the tangent to QDC, wrong one. The tangent to QDC at C, you have to show that they intersect on the circle passing through G, O, and K. So that's the problem statement. What should I call it? Do you want me to run over it again? Because it's a lot of lines. It's a lot of lines, circles, and points. So like, do you want me to go over it again?
Alright, so what do we have? We have ABC is an acute scaling triangle, yeah?
Yep.
In circle, center I.
Yeah.
Touch points D, E, F.
Yep.
A is the midpoint of AI, even though it looks like it's on the circle.
Oh, we could change that. There we go. is no longer on the
circle.
circle.
Okay, and then here's the midpoint of AI. What else? You have circumcenter of ABC is O. EF, it's BC of B. Circumcenter of P. P. E.
PFB is G.
PFB is G.
Yep.
And then circle GKO intersects at U with ABC.
On the same side as A.
That's what is A. Wait, what else? What happened after that?
Oh, you have to show that the circumcircles of QBD and QCD at B and C respectively. The tangents. Okay, wait. The tangent to QBD at B and the tangent to QCD at C intersect on this. They intersect on circle G. Okay.
So you have a circle QBD.
Yeah.
You have another circle QCD.
Yeah.
And their tangents at D.
Oh no, the tangents at B and C.
The tangents at B and C intersect on the circumcircle of ABC.
No, it's a circumcircle of what I call it, GOK.
G. Also, it's one of the circles you already draw.
Yeah. So we'll call this tangent intersection H. You can kind of see, you can kind of guess what the point is, though, which is funny. We'll call this one, we'll call it J. Why not? It's the next thing in the alphabet. So, and I'll color these red to show that we need to prove they're concyclic. And then we can color the circle red. And then we can do the dot as well, so it stands out, right? So, what should I call it? Did anyone have any ideas of what to do with this? No.
That's what it's called.
I think
angle chairs.
I think I gave you all the like at some arbitrary points I did give you all the required tools to solve the question. So I don't know.
Does this require what theory does this require?
Michael point.
I know about that.
Okay, then you should solve it. Easy. Okay, first of all, when we look at this, right? So we can see we have a complete quadrilateral. What do you call it? CBFEPA, right? CBFEPA.
CBFEPA.
Yeah.
Oh yeah.
So we can kind of see a complete quadrilateral, right? So my question is, wouldn't it be nice if Q was the Michael point of the complete quadrilateral? Wouldn't it be nice? It would be nice, right? So
what are we talking about? EABC? What complete quadrilateral are we talking about?
Oh, what you call it? CBFEPA.
Oh yeah, that's what I was saying.
Yeah. So okay, so this is, I think I told you guys about this, but this is what I call it. This is something this is a lemma you can see in EGMO. It's in chapter 10. I remember showing it to you. So okay, we'll move over here for now. So the idea is that for some complete quadrilateral, right? Let's just draw in some complete quadrilateral. Wait. There. Okay, it's fine. Right? So what was the lemma? The lemma was that, okay, let's first construct our Michael point. Oh yeah. So if we have some Michael point here, right? Let here be the Michael point of this complete. Wait, should I use the annotation instead? The annotation might just be easier. Yeah.
Wait. Well, what is the Michael point?
Yeah. Okay.
You took those.
Yeah. No. But I think it's right. So the idea is if we have some. So if we have some complete quadrilateral here, right? Let's call it A, B, C, D, E, and F. That was incorrect. So A, B, C, D, E, F, right? So where would our Merkel point be? Just let's say it's around here, right? So this is our Merkel point M. So what? So the claim is that that this Merkel point M lies on the circle that passes through the circumcircles. I mean the circumcenters of EBC, EAD, FCD, and FBA. Right. So
Can you write that like ABC?
So what you call it? So M lies on circle through. Wait, do you have an ECMO copy on the computer?
Yeah.
It might be easier to just pull that up.
Oh, I don't know. You might go through too fast. I feel like
No, just the diagram so we can annotate. Yeah. Wait, clear all drawings. Yeah.
why doesn't my tab thing come up? It's annoying. No. No. It's probably actually already opened.
Well, yeah, that's a very important one. Anyways. Okay. Meow. We will scroll down. So, do people... Where is it? Do people remember this? Have people seen this?
No.
Okay. So anyways, so what I call so basically first, so we actually use this lemma for the solution. But first, of course, we'd want to prove the lemma, right? So we'll have this diagram here. Here are the what I call it. Here are the what I call it circumcenters of the circle shown in dotted lines, right? So we want to show that they lie. What I call it. We want to show that they're concyclic with point M, right? So, what you call it? Wait, how do you say it? Wait, what? Oop. What does it say? So, okay, so this says what to do. So, okay, so we'll denote the center of PAB as O1. So this point here is O1. And we'll denote the center of PDC as O2. Right, so this point here is O2. So first we show that MO1, O2 is similar to MAD. So we do this by, what do I call it? Well, yeah, I think we'll use using black. So we'll do this by, what do I call it? So if MO1, O2 is similar to MAD, right? It's from similar switch. It's equivalent to showing that MO1A is similar to MO2D, right? And we know that O2M is equal to O2D, and O1M is equal to O1A, right? So it suffices to show that angle MO1A is equal to angle MO2D, right? So it suffices to show that these two angles are equal. Wait, what? Yeah.
So you're saying the angle at O1 is switches to something that stands on.
So angle MO1A is equal to angle MO2D. So it suffices to show that.
Okay, and then the reason was because MO1A is equal to something.
Because MO1 equals to O1A, since M is the McCall point, and O1 is this circumcenter of ABP, which M lies on, because M is the McCall point. That's me, dude. That's me. I am asking for clarification. Like, do people understand?
Okay.
Assuming the thing you said about the McCall point, the length M01 being equal to O1A, and then yeah, I get why we have those two angles are equal.
Do you know why MO1 equals to O1A?
No.
Do you know how the McCall point is defined?
Not much.
The radii was so.
Yeah, because M is the it's the point where the four circles PAB, PDC, QAD, and QBC concur, right?
Yeah.
So that's how it's defined, right? So we can see, so since M,
yeah, I see it now.
Yeah, since M lies on the circle, right? O1's equidistant from them because they're both radii.
Yeah.
Similarly, O2 is equidistant from them since they're both radii.
Yeah, that was.
So to show that MO1A is similar to MO2D, right? Since we already have since the proportions are the same for both of these are both isosceles triangles.
Yeah.
We only need to show that the angle in between is the same, right?
Yeah.
Do you understand that?
Yeah.
Okay.
So what about George?
Right, George, you got it?
I'm more worried about George. I don't actually care about Liam right now. I'm into sleep, so
do you want
let it go?
Well, I understood what you were saying.
But he would only have explained it to you because I told him to.
Yeah,
Just let it go, right?
Do you want me to explain it?
It doesn't have to be very quickly. Like I would like him to explain also. So you're trying to prove that MO1A is similar to MO2D.
So we're trying to prove that MO1A is similar to MO2D, right? So that's what we're trying to prove. I'll just say that. So do you know how McCall point is defined, right? Where the circles intersect. Yeah. So since M lies on circle PAB, right? And A also lies on it, and O1 is the circumcenter of PAB. It means that O1M and O1A are both radii of the circle. So it means that O1M equals O1A, right?
Yeah.
So similarly, we can O2M equals O2D since they're both radii of circle PDC, right?
Yeah.
So since we find that both of these triangles are isosceles, well, it means that it only suffices to show that angle MO1A is equal to angle MO2D if we want to show they're similar.
Yeah.
Do you understand it?
Yes.
Okay.
Wait, so you only want to show they're similar. So when you're saying suffices, you're just saying it suffices to show they're similar.
Yeah.
You're not. It's not suffice to show the problem.
No. It just suffices to show they're similar. Just for this mini lemma, right?
Okay.
So now we want to show these two angles are similar, right? Oh wait, the two angles are equal, right? But note that this angle MO1A is equal to 2 times the angle MPA, right? Since the angle at the center of a circle is twice the angle on the circumference. But note that this is also angle MPD, and angle MO2D is equal to double angle MPD. So that means the two angles are the same, which means we have our triangles MO1A is similar to triangle MO2D. But what does this further mean? It means that from similar switch, right? Similar switch, we get that MAD is similar to MO1O2. So okay, so basically from the condition, we got that these two yellow triangles are similar. Okay, the yellow triangle and the orange triangle is similar, right? So from there, we apply similar switch. And then we can see now that this red triangle,
Maybe not orange. Red.
yeah, maybe not red.
Blue.
I think, so it means that this purple triangle here is similar to this pink triangle here,
Colors.
right?
Yes.
Yeah, it's just similar switch, guys. It's just similar switch.
M0102 is similar to mad.
Yes. I'm mad. Grr.
No, that's the actual question.
Yeah. So, whatchamacallit? So, how do you say it? Like, whatchamacallit? Okay, how do you say this? How do you say this? Uh, oh, this is a speaking difficult. This is a speaking issue. This is a communication.
What are you trying to prove now?
You're trying to prove that, like, since MO from this, basically, you're trying to prove from this result that whatchamacallit, that the 5 points are concyclic. That M01, O2, O3, O4 are concyclic. Okay. So now we'll eraser everything to make it clear in there. Alright. I guess how you would express it is that, okay, okay, I don't want to say similarly because there's like additional things to consider, but like it is similarly you get okay, maybe should we do it again? I think we should do it again. So okay, let this point be O3, right? In the yellow. So we're gonna try and prove we're gonna try and do something similar, I guess.
M02, O3 is similar to like.
Actually, we want M01, O3, right?
Oh, I mean.
Yeah. So you want to prove that M01, O3 is similar to something. I believe it's similar to this one here.
MAQ.
Yeah, triangle MAQ.
That looks believable.
So what's that equivalent to? By similar switch, we can instead show that we can instead show that that MO3Q is similar to MO1A. And like before, yeah.
Yeah, we should probably even be the same group. We swapped around.
Yeah, because they're both double of angle MBA. They're both double of this angle here. Right? Yeah. So we'll just gloss over that since it is kind of the same proof. but like I guess it's worth it to show that it's also true here. So from there, so okay, like just by kind of repeating it, we get that what should I call it? We get our desired similarity, which is M0301 is similar to MQA, triangle MQA, right? And also we got triangle. Oops, undo. We got triangle M0102 is similar to triangle MAD. Wait, I should make it blue and red, right? So from those we established that M0102 is similar to which triangle? MAD. Right? So the two red triangles are similar. And we've also established that the two blue triangles are similar where so MQA is similar to M0103, right? So from there, we find the angle O1O2M, right? So let's run it in black. Angle M0201, what's this equal to? It's equal to angle MDA, right?
Yeah.
Which from what shall I call it, because of the similar triangles. So what's angle MDA equal to? Since MADQ is cyclic, we find that MDA is equal to angle MQA. And since MQA is similar to triangle M0301, we find that MQA is equal to angle M0301, right? So we find that M0301 is equal to angle M0201. So this means that M010203 lies on a circle, right? So we can so from here we can actually apply something similar. So with this 0.04 here, just in green. So we can do something similar with M040302, right? So we can also show that M040302 all lie in a circle as well.
Wait, so when you which angle did you show was equal to MDA? Did you show it was M0301 first, or did you show MQ?
What you call it? It's M0102. I mean M0201 is equal to MDA, which is equal to MQA, which is equal to M0301.
Oh, because it's on the which circle? Why is it equal to M? Oh, because it's on the circle MQD.
Yeah, MQDA, yeah. So do we get it?
I guess you didn't really need the similarity, but it's nice to know it, huh?
Yeah,
You can just change the black angles directly, like
I guess, but yeah. Like what you call it? You follow the Evan Chen exercises. That's
like the O2 angle is equal to the D angle because of the cycling.
is it?
Oh wait, is it cycling or not?
No, because
No,
no.
because of the similarity, right?
Yeah, it's because of the similarity.
Yeah, and then you use the cyclic to get
Yeah.
and then it gets you the other one.
Yeah, and then you can get the other one through similarity again.
Yeah.
Oh wait, so that circle is the actual conclusion, the one that's drawn in the middle.
Yeah.
What was I doing?
Bro, he's doing his skyblock grind, bro. That's what I'm saying, dude.
So any
Did you get this drawn? Oh.
What do you mean by I guess? Do you know how we got M01, O2, O3 is concyclic?
equals
Oh.
Okay.
That took away now. Because the left hand.
Yeah.
I feel like Michael's very going to just be blanketly banning laptops in his class.
I think it is a laptop removal angle. personally. I personally.
No.
Gave people a lot of freedom.
On
and-
Monday, he took away 2 devices. It
Ooh,
was a
I'll check it out. They take away your phone for texting. Oh.
on a, yes, but like
Okay.
I didn't need to text.
Oh wait,
Monday.
wait, George, do you get it? You want me to explain it? In 30 seconds. Okay, that's that's an interesting parameter. Why 30 seconds? I'm quite curious.
Like,
what is it he's doing?
I don't know. He's on the grind. That's all I'll say.
What does that mean?
It's
Curious.
on the grind.
I'm curious as well. Oh my!
Okay, 2
Too much
seconds.
freedom here.
Let's go.
Imagine if parents ever walked into you running a
It's just 2
class.
seconds. What happened?
3 seconds.
You said 30 seconds quite a bit ago. I will say that.
I said 30 seconds, 20 seconds.
Not really.
Alright, let's think about what would happen once it's true. So you got M01, 02, 03 is cycled. So they just keep doing it to get all of them cycled.
Yeah.
And then what else?
Yep, that's the idea. You need that's the lemma you need. But it's a lemma I remember I showed this lemma before. So
I remember Yasuo talked about something like this.
Okay, this is not 30 seconds.
Right, laptop over here. That should be inconvenient. Right. Now welcome to a life in life.
Hey, wait, you almost promised said 3 devices on Tuesday.
What is this becoming?
Michael coming to understand giving freedom.
All this time I thought you were just taking up maths. As if the dollar signs weren't enough motivation.
okay, so we established earlier that M0102 is similar to M80, right?
Yes.
We use a similar method to actually get that M0103 is similar to MAQ. So let's just assume that's true because the way to prove it is the same way, right? So we get that angle M0201 is similar to is equal to angle MDA since the 2 right triangles are similar. So they have the equal angles, right? You get that? Okay, so from there, angle MDA is equal to angle MQA, right? Since oh wait, can you say why? Why would angle MDA equal angle MQA? So this black angle here is equal to that black angle. Okay, so
It's like those 3.
no. It's because what you call MADQ is cyclic. MADQ lies in a circle. Because how we define that, right? So since that's concyclic, right? We get that MDA is equal to MQA here. You get it? So now since triangles MQA and MO301, they're the blue triangles, right? Since they're similar, we find that angle MQA is equal to angle MO301. You see that? So the similar triangles, so since they are similar triangles, they have equal angles, right? So from there, we got that angle MO201 is equal to angle MO301. You see it?
So the black angles of the blue triangles are equal to blue triangles similar. The black angles on the red triangles are equal to the red triangles similar. And then one of them are equal to the other because it's some circle.
Yeah. So from there, since angle MO201 is equal to angle MO301, right? Just from our angle chase, we find that M01, 02, 03 is concyclic.
Yeah.
Yeah. So that's how we got our result. So and then we apply this like symmetrically to M04, 03, 02. Get that those are cyclic, right? So that means all 5 of them are cyclic. Yeah. So you get that?
Yeah.
Okay, that's good. Okay, anyways. What is the importance of this result?
That's the thing on that problem, right?
Yeah,
Q
okay.
is the Miguel point.
Q is a Mikkel point, but there's actually a special name for it. What should I call it? That's specific. Okay, where's the Google? How do I go back to the Google? Oh, I got it. I got it. Oh, I got it. I did not work. Okay, we'll clear all. And then we will go back. So, what did we notice? So, something we should have noticed is that G is the circumcircle of PBF, right?
Oh,
Yep.
K is a K is a circumcenter of AFE, right?
Yeah.
Because
that's the diameter.
yeah, because AI is the diameter, right? So and O is the circumcircle of ABC. So we know that the Mikkel point lies on the circle, but note that the whatchamacallit, the Mikkel point also lies on circle ABC, right?
Yes.
So
Use the intersection.
is Q necessarily the Mikkel point?
Oh.
What if it's the other one?
What other points pass from Q?
What?
Because it's two circles. They have two intersection points.
True.
But how we defined it is that it's on the same side as A.
Oh yeah.
So that means it has to be. Because if it's on the other side, right? If it was on the other side of A, that it just won't work. It's just
Yeah.
like the Mikkel point has to be on the same side. So whatchamacallit? So we know that this is the Mikkel point of this complete quadrilateral that we've outlined before, right? So what does this mean? So it means if we draw a circle A, E, F.
We can still submit this problem to some distant country.
So A, E, F, right?
We
Bonk.
submit it to Russia.
So we considered. So we can see that this Q lies on circle AEF, and Q is actually the intersection of AEF and ABC. Now, what does this mean? Do you know what the point's called? I don't know how well known it is, but like, considering everyone around me knows the point, like, but everyone else is a cringer. Cringer config geo America handout reader. This is actually called this is what we refer to as the Sharky Devil point.
What?
I've heard of that before.
What's it called? It was actually. Ooh, I might go. I don't think I'll go to etymology.
Anti-theory terminology.
The Sharky. I've heard that name before.
Yeah, Sharky Devil is kind of well known. Yeah, it's an America handout. Like, if you're in America, you should. If you're a Malper, you should know it. Anyway.
Go to
What's it called? I don't know. Okay.
Wait, what did we just do in that last segment? So we have the circle. F is the Miguel point,
Yeah.
Now we concluded.
which was actually Q, but now it's changed.
Yeah, because that's what the Sharky Devil is denoted as. We denote it as S for Sharky Devil.
Now it's become the Sharky Devil point.
Okay. Yeah. Okay. So here's a pretty cool lemma. So if J is the mid arc of VC not containing A, if and D is the encircle touch point, right?
Yeah.
STJ is collinear. So we can draw it in right now.
Oh.
D-
Wait, is J the actual mid arc?
yeah,
What's
J
J?
is the mid arc.
Did you show J was the mid arc?
No. But we can
Well, it's defined. Is it defined that way?
no.
What's the definition of J?
It's the intersection of the tangents of like SBD with at B and SCD at C.
Oh, in the question set.
Yeah, but like whatchamacallit?
S E.
But if we show that SD and the mid arc are collinear, we'll call the okay, for now we'll hide J. We'll pretend J doesn't exist. We'll pretend the tangents don't exist. We'll pretend the circles don't exist either. Right? We'll even pretend this circle doesn't exist.
What?
We'll just consider the perpendicular bisector here, right? And we'll call this point M, right? Which right? So 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 it's a decently well-known lemma that SDM is what I call it collinear. But the question is, how do you prove it? I've actually
You're just doing like the circumcircle diameter AI.
what I call it? Circle diameter AI intersects ABC at S. And you show that SDM is collinear, where D is in-circle touch point with BC, and M is mid-arc of BC not containing A.
Oh.
No, what should I call it? I think I've shed light on how you might have done. You might be able to do this. What should I call it? Should I reveal it or should I let you ponder for a bit longer?
What do you guys think? Where's Justin? What's Justin doing? Justin, where art thou?
Justin, where are you? Wait, where's Justin? No. Okay, we have to pull up the chat. We have to pull up the chat. Mr. Justin, where are you? This is it. This is it. We've lost someone. We lost someone.
Maybe he's solving the problem.
Maybe he is. Should we?
Alright.
Something was like given.
Wait, maybe you should name it E instead of M.
Why?
It's like Shaggy Devil.
No,
sorry.
Oh, there's already a P. There's already a P on the far left, so
That's
it's gonna be
stupid,
a bad one.
sorry.
Then it's gonna be a bit. Okay, so I think I've okay. I think we've done. George is definitely what I call it. George might be able to figure out what you do here because you were here when we did a question where I solved it using a cringe way. Okay, should I just say it?
Right, so we're trying to prove SDM of the linear. Yeah?
Yeah.
Of two circles. Oh, that's the in-circle.
Mm-hmm.
What Justin replied.
Oh, he was getting water. It's all good. It's all good. His back is back.
Alright, Justin, can you
Would that be?
Wait.
Justin, right, so close, remind Justin what we're doing.
What? Remind us of what we're doing. Okay, so we changed Q to S because it's the Sharky double point. What should I call it? So we defined S as the intersection of circle diameter AI or circle what should I call it? Circle AEIF intersects circle ABC. Again, right? So that's our point S. We define our point D as the touch point, as like we did in the question, and we define point M as the mid-arc of BC not containing A. And we want to show that SDM are collinear. We should probably dotted this. We want to show that these 3 points are collinear.
So AIN is clear.
Hmm. Should I say the magic word? The magic word.
Is it inversion?
Yes.
Wait, because if you invert, it'll be on a circle going to the center, right?
What?
Wait.
But why do you invert about?
Or what is that? You invert about.
Maybe we should invert about the incircle.
Yeah, that's what.
Do people remember where M goes? Out of interest.
Teach us about inversion.
Wait, does M go to I?
No.
Okay.
George should remember. He was here for it. Why does if we invert about this whatchamacallit? If we invert about the incircle, where does M go? Can you describe to me where M goes?
So M stays on the line. There's in circle.
Okay, let's just draw DEF first. Let's make it green. It's DEF, it's green.
It can be done with angle tracing, right? Linearity.
But why would you do it with angle chasing? Because it is going to be infinitely harder.
Infinitely harder.
Like the inversion is the easiest way.
The easiest way. These claims
Like, okay,
invoke the trust.
okay,
That's why he wore a t-shirt with the word trust.
okay. Wait, George, do you remember this? Wait, what?
George, I believe the correct tense is I am failing.
Okay, do you remember this? So let's say we have a triangle ABC. That's foreshadowing, that's foreshadowing. With circumcenter O. We invert about A. Where does O go?
Hey, where's code? We did talk about this.
Yeah, we did.
Is this like Iran geometry?
No, around them was something different. This,
Yeah.
it was for.
Is there an Iran question?
I think it was Balkan. It was Balkan Q2. So, okay. Just, if we invert about A, where would O go? I mean, what do I call it? With respect to B and C, like B prime and C prime, what would O prime be under inversion about A? Alright, so let's just draw red angle, and green angle, green angle. Could you tell me anything about triangle A, C prime, O prime? What triangle would it be similar to?
AO prime. AOB.
So triangle A, O prime, C prime. It would be similar to triangle A, C, O. Right, because that's how inversion works.
preserves angles.
Yeah, inversion preserves angles.
Yeah.
Right.
Yeah.
It doesn't really preserve angles. The like things are switched, but like you want to talk about. So the idea is triangle ACO will be similar to triangle AC prime O prime, right?
Yeah.
So let's just draw our inverted diagram here. So here's A. Let's say
That's more just definition of inversion.
yeah, it's the definition of inversion. So this will be point B, B prime. This will be point C prime,
But it's hard to guess that's what you want because it's not really clear what you're gonna do with it.
right? So O prime. So we find O prime is the point such that A B prime O prime is yeah. So yeah, triangle AB prime O prime, it will be similar to AOB, right? So what does that mean? It should mean that AB prime is equal to BO prime. Since whatchamacallit, could you see that? Since AO equals OB and AOB is similar to AB prime O prime, we should also get that AB prime is equal to B prime O prime.
Like, if
Wait, what?
what is
A is the center of inversion.
Yeah, A is the center of inversion.
What's the point of this? So your conclusion is what's your conclusion?
What's the word called? Conclusion is that okay, close enough. The conclusion is that O prime is a reflection of A across B prime C prime.
Oh what?
don't like I remember this, but I don't remember.
Do you remember it?
Like I remembered, but I don't.
Do like people have a clue on how to prove this or like why this is true?
O prime is a reflection of O about B prime C prime. What is it?
A.
About A.
Yeah.
Oh.
Do people understand it? Why it's true?
Does it matter what the radius is?
No, it doesn't matter what the radius is. Because the triangles will still be
So we know that it's similar.
yeah, we know that A B prime O prime is going to be similar to A O B. Yeah. And similarly we know that A O prime C prime ACO, right? So from there
In that case, then
we can see that these two green angles are equal and those two red angles are equal, right? A O B prime is similar to A B prime O prime.
You're kind of saying like A O prime B prime is isosceles.
What's it called? Yeah.
With the same angles.
Yeah.
But you just need this isosceles.
Yeah, you just need this isosceles. What should I call it? You just need this isosceles, but it's isosceles with the same angles.
Oh, so you get like a kite.
Yeah. If you draw the line in the middle, it's congruent by SSS. So it means that it's a reflection. I swear we went through this already, yeah.
But I also don't.
Do you remember why we got that straight? Do you like remember the general idea? Like for what do I call it? Do you understand what we're doing?
Oh, I see how that's useful for that other thing
Yeah,
because we take
because
I M's the
circles.
of IBC.
But what do I call it? That's but
Good notice.
yeah. Are we gonna move on from this, or do you want to like? Should I explain it more?
I think people get it, yeah.
Do people get it?
George, do you get it? Like, can you
So basically, there's one, like, A or B is similar to A O prime B prime.
Yeah.
That's
Like-
supposed to be
Is that like
the definition of
Yeah, that's just like
well, like in
Based
that
on
case?
yeah.
because of, like, you know the diagram, right? It's like, it's kind of like triangle with like another. Maybe draw that triangle.
Draw what triangle?
Draw where B and O are relative to B prime.
Ah, that's
So I
right.
guess now this diagram becomes this B prime might be inside B or outside. You know? But you'll draw one of them.
Okay, so we'll just draw like. Oh, straight line. I think that was accidentally a straight line. We don't like straight lines here. We like queer lines.
What?
Don't worry
I
about
like
it.
straight lines, okay? It would not be ideology class.
No. Okay, we need to make this.
These videos.
No. Oh, okay, there we go. That's. Okay.
Straight as an arrow.
Okay, let's just say O is here. And B is here. I should do it in a different color. Okay, I'll do it in red. So B would be here and O would be here. And we would have
Oh yeah, I see what.
yeah.
What strip?
AO times AO prime equals AB times AB prime.
Yeah. So do we see it or do you want more time? So we're all good?
But you get it, George?
Hmm.
They have a common angle.
Yeah.
And the sides are in ratio, right? So it's SAS, but it's switched. So OB corresponds to AO. Yeah. AB prime corresponds to AO. Yeah, and then because AOB is isosceles, right? Because it's radii of a circle. And then O prime B prime is isosceles. Okay, so for us then M reflects about B prime C prime.
Yes.
Yep.
What is B?
Okay, so we'll clear we'll clear drawings for now. Okay. So do we know where B and C go under the encircle inversion?
Somewhere in well, if you line up with M now. Fine.
What I call it? So okay, so the idea is that
Oh, the tangent, yeah.
yeah. So B prime is just here, C prime is just here. Actually there's a circle inversion tool. There's an inversion tool. So I should B prime goes there, C prime goes here. C prime goes here, right? So we can see that M is a reflection of
I.
I over B prime C prime, right?
The M prime.
So we also know that B prime C prime is the midline. Wait, no, is it? You call it the mid? Like B prime is the midpoint of DF, and C prime is the midpoint of DE.
Oh, yeah.
Like, can we see that?
Yeah.
Can we convince ourselves that's true?
Yeah.
Okay, that's good. That's good. So, so we know where M prime goes. Do we know where D goes?
It's
Where D goes.
Yeah.
Oh, yeah.
Oh yeah.
Okay, that's good. That's good. Okay,
I know where S goes.
Where does S go?
Of course we know about dingoes. Oh, what?
Okay.
What?
Okay, so here's the idea, right? So S, okay, so S is the intersection of circle ABC and circle AEF, AEIF, right?
Hmm.
Where does circle AEIF go under inversion?
FE.
FE, right? It goes to line F. Where does circle ABC go? Do you know?
Oh. So what?
ABC.
Oh,
Where does ABC go under inversion?
wow, we know where B and C go. Uh-huh.
You can just do the same.
Where does, well, my question is, where does A go? I think. A should be easy. You should be able to tell where A goes.
It's just the
Midpoint of yeah.
yeah.
Midpoint of EF. Damn, that's crazy, dude. That's crazy. Right? That's my bad. That's my bad. That's my bad. That's my bad.
That's not mid. Wait, another thing. What does that even mean?
Okay,
All these leads speak.
so ABC. So circle ABC goes to A prime B prime C prime.
Yeah.
Circle A through A prime B prime C prime, right?
Oh, yeah.
My question to you is, with respect to DEF, what is circle A prime B prime C prime?
Nine.
What is it?
I am sure.
So okay, what?
The medial triangle.
So
Yes.
so
You
what?
already said.
So it's the
But
medial
the
triangle, but
circle
what's the
has a-
circle? What's the circle?
Euler produces
NP. Is it the NPC?
It is the NPC.
9.
It is the role player.
Yeah, it is a non-player character. You're extremely you're correct. So since S is not A, right?
The 9-point circle.
Yeah, the 9-point circle.
I am so behind.
Okay, so actually,
Falling.
Sleep.
okay, actually, so since it's the 9-point circle, right? So we find that okay, so we find that S is the intersection of the 9-point circle with line EF. But we know like S is not A.
Yes. Is that
So what is the other point?
it's the intersection.
What?
It's the,
Yes. This guy making me proud.
So can you say it again? So what would
also the altitude from the
that's extremely correct. Okay, so now my question to you is to prove SDM is collinear, what is the equivalent statement under the inversion?
The circle
S
goes through
wait SB wait
S prime.
S
D
prime
M.
D M prime I is cyclic.
Yep, that's right.
D prime M prime I.
Okay, so we know
I M is parallel to SD. The S
that's a
prime
good
D.
observation. That's a good observation.
Just very good.
We also got
That's-
the reflection.
Oh yeah,
because
it is
it
true.
is- yeah.
Yeah, it is parallel.
So if it's parallel, right? If a quadrilateral is parallel, it's a
It
trapezium.
has to be an isosceles trapezium.
So you know where to go. So how could we prove this is an isosceles trapezium? Knowing that M prime is a reflection of I across B prime C prime, how would you show it's an isosceles trapezium?
S prime is a reflection across B prime. Yeah,
And that's just
yeah.
That's just true.
Is it just true?
Could you explain it to me in more words? I know you got it, but like just like briefly outline it.
No, I don't have it, so I need to be explained to
so
as well.
like B prime is in the
Yep.
Mhm.
and C prime is the mid.
D.
DE.
Yeah.
Yeah.
And so the intersection is DS prime to D.
Because that's
The
triangles
midpoint
are right?
of DS.
Oh, it's like equal intercepts on parallel lines.
Yeah.
So that means we get our S prime I M prime D is isosceles trapezium,
Yeah.
or SDM is collinear,
Yeah.
Yes.
as desired.
You claimed this was the easiest way. It is definitely the coolest way. I can probably vouch for that.
Like, my question is, how else are you gonna really use your D and with your S? That's like, I don't think there's not many ways to use it. Like,
Why did you just point at me at the moment someone said D?
what?
Why was I
think
just
you brought this upon yourself?
Okay, so we'll get rid of everything because that was just for proving. Okay, we'll get rid of.
That was quite epic.
That wasn't epic.
So
We
now,
learn about inversion constantly.
now
Still never seen.
we can claim that our
It's making more sense now.
so now with our so now we have our thing where it's the intersection where okay, so now since MDS is collinear, we can now kind of try and make sense of what does S like tangent to SBD at B intersects tangent of SCD at C. We can kind of try and make more sense of it. We can make the claim that M is actually the intersection of the tangents. The midpoint of the arc is the intersection of the tangents.
What?
How do we get there?
What's your
Okay, so we're
call?
back to the original problem now.
Yeah.
And somehow, what's your definition of M here?
M is just a mid arc.
It's the middle.
Oh wait, no. Wait, what's your call? We'll replace M with J.
You just have to check some angles equal so that it's tangents.
Oh wait, no. Just keep it M. Just keep it M. Because look at this. What's angle MCD equal to?
MC.
I'm trying to work out what was the actual circle you said was tangent to?
It was SBD at B,
Right, and then it's
CD at C. Yeah.
Okay, yeah.
So what does angle MCD equal to?
It's supposed to equal MSC, right? Is that what-
Yeah.
Yes.
What's well, you know the angle MCB is equal to angle MBC.
Yeah.
Yeah.
And then
And then
uh,
and then
Alternate segment, right?
yeah, and then you bow tie.
yeah.
Yeah.
And then you see that angle MBC is equal to angle MCB, which is equal to angle MSB.
Which is alternate segment.
So so it means from
Yeah.
converse to alternate segment. Wow, MB is tangent to SBD.
Oh my goodness.
And then you do the same thing for the other side. Wow, M. So that means the tangents intersect at M. Right?
Oh.
We're trying to begin the tangent intersect on the circle.
Not this circle, the other one, the red circle.
Right, so
So now we just need to prove that M's. Wait, isn't M the what? Interesting.
How do we say it? Remember how we proved that that this point S was the McKell point?
Yeah.
Do you remember the proof?
this point S is the Michael point. So we proved that it was the.
Oh wait.
So it was on circle.
It was on the circle of ABC and the circle of the centers, right? And it could be on the other side of A. Wait, and
Okay. So my question to so my question to you is, what would triangle SKO be similar to? Remembering how we proved the thing, right? What would it be similar to? Remember, S is the Michael point.
Yeah.
Our thing is A, F, B, E, C, P, and spoiler, we're not going to use P.
But now we're trying to prove M lies on the red circle. Is that the
Yeah.
it's like two of the vertices?
Yeah. But which two vertices? Which two vertices do you want to conjecture?
And
Ideal vertices. It's your choices are between
B,
B,
C,
B, E, C, F, A,
B, C, F.
what's the
P.
P?
We're not using P. That's my spoiler. Like, oh, that's my hint. But like, I'm just not bothered to zoom out.
Right.
It's not P. Just
There's only SF.
SFA
SFP.
looks similar.
Mm, it is.
I'm pretty sure that looks roughly like what
It's
we
like the
had in the
AD.
previous.
Yeah,
AD of the
Yeah. it is. So we get. So, do you want to run through it again, or are you fine with just like the claim?
That's the same thing as
Yeah, it's the same thing as before.
Yeah.
So we get that SKO is similar to SFB. What does that mean? Angle SOK is equal to angle SBA.
Yeah.
But what is angle SBA equal to? It's equal to angle SMA, which is equal to angle SMK. So what can we say? Since SMK equals SOK, it
Yeah.
means the
it's cyclic.
yeah the 4-point circle cycle. So that and then you're done.
Oh, wow. It's geometry.
So yeah,
But what's the most rating of this problem?
it's not that high. It's like hard. It's hard cap at 20. But it's probably not 20 because the configs are.
Which country should we submit to? Submit the video as a solution.
That's what
Make money.
15 to 20 M.
And
$20.
So this is like high 15 M to low 20 M.
Probably not.
no, this is like. Okay, so this would be like
It's really config. It's
I
not.
don't. I haven't tried the problem, but just looking at this solution, probably like 35 M.
No, it's not.
We determine.
No,
I'm just comparing it with the combi we just did.
We determine.
Huh?
We determine.
Which combi
Pretty much just that haven't changed that much at all.
it's 10-15 because the configs are very long. Okay, actually 15. Actually 15 makes sense, I guess.
15
15
M
does not
combi
make
is
sense.
so much. Like,
No,
Because the configs are well known. It's like the configs are more well known than 20M ECMO Q6 configs.
the well-known doesn't make the problem easier. Do you
so
understand?
basically, if you. It's like.
Well-known doesn't decrease the rating. It actually increases the rating.
Huh?
Yeah, obviously.
How does the more well known, the higher the rating?
Well, if you need something well-known, it increases the.
Well, but the well-known things are very well. So, like checking down was comical. And also,
And it's not like you just did one. You did a sequence of them.
whatchamacallit? Yeah, but like, whatchamacallit? It's just Sharky. The Sharky double collinearity isn't that
I think this argument will need to be resolved with authority.
bad.
Was 2023 IMO 6 bashable by Barry Bash? Was it or not?
Whatchamacallit? Dotted said he tried it, but he got 41.
41.
Yeah, Dotted missed Dotted.
Who's dotted?
Oh, no, it's not one.
He did it in the exam.
Oh yeah.
He went to the IMO.
Yeah, he got 6 for it.
Did he Barry back it?
Yeah, he got 6.
In the actual IMO.
Yeah, I'm pretty sure he used the 7th one as well.
This really?
Okay. Because that would disprove this 0 or 7 BS.
Yeah, because he forgot to show the intersection. The intersect.
Oh, that was, yeah.
The-
They intersect, yeah?
Yeah, what should I call it? Yeah, because he got called out in the eye, and like, they straight called him out for like.
Oh, and
so
see, we were more rigorous in Boston.
okay, I
What's his
think
name again?